Hi, this talk is about our paper Efficient Nearest Neighbor Prompt-Based Learning for Few-Shot NER in Manufacturing. Our paper appears as a SMEC presentation at SMEC 2024. It is a joint collaboration with Pei-Yan Wang and myself. NER in manufacturing involves entity types such as part, attribute, material, and accessory in various documents related to mechanical manufacturing. In this example, Hicheng-Shin-K Syntec Core is an entity of accessory and 25M1in is an entity of value. In manufacturing, the morphology of characters contribute to its overall entity meaning and word formation. For example, in the entity air cooler, the first character denotes temperature properties, the second character serves as a fluid medium, and the last character represents equipment. Diving into the actual production of the paper, we start with the motivation. Two main characteristics of manufacturing-related texts result in a limited number of annotated samples available for training. First, there are 11 types of entities, which much more than entity numbers of general domain. Therefore, there are fewer entities of each type compared to the general domain in datasets with the same number of sentences. Second, the annotation of manufacturing-related text imposes a significant challenge as it requires expert knowledge. Recently, prompt-based learning has succeeded in few-shot NER by exploiting prompts as task guidance to increase classification efficiency, but this works did not fully learn the morphological features of character in the manufacturing entity when labeled data is limited. Issues, we propose a nearest neighbor prompt-based learning model NenPlum, which utilizes the instances-based retrieval to enhance the template-free prompt tuning method and achieve competitive results for few-shot NER in manufacturing. Besides, existing manufacturing-related texts have a phenomenon of multi-category characters. These characters refer to those characters with two or more entity types. Since the representations of the same characters in different entity types still have a greater similarity than those of two different characters, the character representations from PLM perform poorly in retrieving similar morphology of characters. Therefore, we propose a supervised contrastive learning skill term in the instance weighting method to address such challenge. This skill pushes character representations from the same label close and character representations from different label feature apart in the space. The NPLM consists of three parts: the NTM module, the NADule, and the Viterbi module. During inference, the probability distributions of each token are obtained from both the NTM and modules. These two probability distributions are weighted and summed, and the result is fed into the Viterbi module to obtain the final label sequence. Next, we introduce each part details. For the vanilla NER model, we use a template-free prompt tuning method, entity-oriented NTM, for few-shot NER in manufacturing. In NTM, the PLM is fine-tuned to predict label characters instead of the original characters at the entity positions, while still predicting the original characters at non-entity positions. Then, in order to enhance disparity between representations from different labels, we introduce skull term to fine-tuning PLM. The skull pushes token representations from the same label close and token representations from different label feature apart in the space. In this section, the data store is the set of all key-value pairs constructed from all labeled characters in the training set, where the key is the representation of characters and the value denotes the labeled entity type. In addition, we also introduce a weighting factor to each key to modify the distribution of KNN. The key is given a weight proportional to the similarity it causes. The larger is the negative difference between the mean distance of keys from the same label and the mean distance of the keys from other labels, the larger is the weight. Diving into the results, we can see that first, NenPlM improves the competitive baseline NTLM by 7.2% in average F1 score on all few-shot NER datasets. This indicates that NAN module is able to provide task-specific instances information to enhance prompt-based model. Second, we can observe that with the decreasing number of the training examples, our model tends to achieve greater improvement. Even the data store is also limited by the low resource. In addition, we ablate the NAN module and skull objective to validate the effectiveness. NAN-only data store means only using data store in NAN module and is described by alpha 1 in the weights. Data store weights donuts using data store and weights in NAN module without skull. Skull indicates the fine-tuning by our proposed NTLM SCL without NAN module. From table, we notice that NAN data store weights, NAN data store. Weights and SCL perform significantly better than NTLM, demonstrates the effectiveness of NAN module and skull objective. Moreover, when the number of instances is less than 200 shot, NenPlM performs a little better than such methods. This demonstrates that the superiority of our framework in few-shot manufacturing NER. We also explore why adding skill objective better than only end-to-end by visualizing representation We train PLM on 5-shot setting and use T-snare to project the high-dimensional representation into 2 dimensions, where the high-dimensional representation are the last hidden representation from PLM. In figure, we can clearly see that the skull term enforces more compact clustering of characters with the same label, while the distribution of the representations learned with only ent-elm is close to random. Note that a few representations from ent-elm overlap with representations in the other entity types. In our method, the representations of different entity type are separated clearly. Therefore, our method rectifies the prediction caused by the representation of predicted character is more likely to fall into the cluster with the gold label. Finally, we select a typical example to better illustrate the amendment by retrieval 4. The input sentence, He Cheng Shai Yufeng Washin Bianyuan Jijibat joined between synthetic core and honeycomb core edge. He Cheng Sin K synthetic core belongs to the accessory entity. The ent-elm makes an incorrect prediction as this model does not fully learn the morphological features and multi-category characters phenomenon in manufacturing under few-shot setting. However, NANPLAM rectifies the prediction by retrieving the nearest characters with a similar morphology, such as He combine of He Cheng Sin Kai synthetic core and Rong fusion of Rong Ji solvent have similar meanings and are both the first character of the entity and avoiding the same characters with different labels. There are some bibliographical references in our paper. Thank you for your time.